Yeah, let me get that mic. I don't put it on right away, I always forget it. Okay, so we graded the test, and the average for the midterm was 89, but Shauna just told me that the standard deviation was 12. So that's a pretty big standard deviation. Remember, the variance is that squared, right? So the variance is 144. It's not that bad, but also remember that the course grades will be curved. And we did give another homework assignment and some extra credit yesterday. Remember also that the homework counts 1/3 and your project counts 1/3. Now,
oh yeah, I put out the dates for the project. So could you remind them to submit the presentation next Wednesday and the report first August.
okay, so when are we going to start the presentations?
Thursday, next Thursday.
Or can we start them before that?
But they will need time to make the presentation. So
Okay. We could even start them at the end of this week.
we could, if we get some from them.
Okay, here's what we're going to do. We're probably going to finish up, maybe even tomorrow we might be able to finish up. But we definitely could have a presentation on Friday. Now, anybody who wanted to present on Friday, we'll give them extra credit for doing that, okay? And then we'll continue on. So anybody who presents before the Wednesday will get extra credit for the presentation. So get in touch with Shauna if you're interested in that. And remember, that will add right on to the extra credit grade. And that extra credit grade, that project grade, no, it won't add on to the extra credit grade. Let's add it on to the project grade. That project grade counts 1/3 of your total grade. So that's important. And I think a number of you probably have enough to do a presentation. Remember, a presentation is almost like an outline of your paper. So the presentation doesn't have to go into excruciating details. And in fact, we want to keep the presentations to, I don't know what we said, 15 minutes?
Yeah.
In 15 minutes, you can't cover a whole lot. And remember, if you have a group, let's have just one person do the presentation. Everybody will get the same grade and the same credit. But it's a lot easier than, sometimes groups like this, somehow they think that if everybody doesn't get involved in the presentation, everybody won't get credit. But we don't do that. So, and that makes it a lot easier because this shifting of speakers wastes a lot of time. The 15 minutes is not a bad idea because, say like in professional meetings, like for Informs, the Orsa Tim's society, when we have a conference, that's typically what we give is 15 minutes for a presentation. So you'll have to learn how to be short on that. I know 15 minutes is not a lot, but you can expand in your paper. Just view the presentation as an outline for your paper, okay? And I think Shauna probably, did you put up an example paper?
Yeah.
Okay, that's great. Okay, so let's see, we're going to continue on with option pricing. And we talk about the extra credit. Last time, yesterday, CNBC, they said that the NASDAQ 100, that's the top 100 firms on the NASDAQ in terms of capitalization, by yesterday was up for 14 straight days. And that is the longest winning streak it's had since 1960. So it's really been way up there. Now, of course, when you see NASDAQ, and this is where we ask an extra credit, the NASDAQ you see on CNBC or in the newspaper is typically the NASDAQ composite, not the NASDAQ 100. So I encourage you to look at those small extra credits because they actually do something here. Okay, let's see where we were. Oh, we were just about in the binomial lattice model, we were just about to say, how do we pick these factors U and D, the up factor and the down factor? In that binomial lattice option pricing model, how do we pick the up, which is, we just say U, and down, the factors. And of course, these are the one period factors. So now, let's see how we pick them. We let U equal E, the base of natural logarithms here, to the sigma delta t. Now, delta t, of course, is our period length here. And we let D equal E to the minus sigma delta t. Okay. And now, what are these? What is the sigma here? The delta t, of course, is the length of the period. We'll state that too. But let's look at this sigma. Sigma equals the standard deviation of the asset, typically is stock, price, movement, per period. Okay. And we can say that that's the volatility. This is not exactly the volatility. Sometimes you'll see on CNBC they'll have the volatility index. This is not this. And delta t, say where, delta t equals the period length. Or the time step step size. Of course, as we let delta t go to 0, we approach the continuous. Okay, let's see if we can get a different color pen. Good. Now, let's look at our continuous model. So that does it for the discrete model. Now let's look at our continuous model. And our continuous model is much more complicated. Mathematically. And a lot of that complication we're just going to skip right over. In fact, we're going to skip, you'll see Ito's lemma in here, that, well, we're going to skip that derivation of the Black-Scholes. But we're going to jump right to the Black-Scholes equation. Look at the famous Black-Scholes equation. Okay, this was my Fisher-Black and Myron-Scholes in 1973. And Myron-Scholes and Robert Merton the two of them got received the 1997 Nobel Prize in economics. Unfortunately, Fisher-Black had passed away by 1993, and the Nobel Prize is only given to people that are still living. Okay. Also, I think at least one person is doing the history of hedge funds. In fact, maybe tomorrow I'll give it. There's a very good book that's a reference. It's called More Money Than God. It was an excellent book for anybody. And you can get that on Amazon, or you can buy a used copy here. One of the famous hedge funds had Merton and Scholes as the original partners on the fund. That was long-term capital management. And they thought that since it had Nobel laureates involved with it, a lot of people and big banks dumped a lot of money into that. Now, that hedge fund went belly up, amazingly. They made some bad bets on the Russian ruble. They thought that it would be once in several hundred years that they could lose money, but they definitely did lose money. And so the government had to bail them out, because that was the first bailout, because of all these institutions that had invested with them. It would have dragged the whole U.S. economy down. So they were smart, but not smart enough. You got to remember, these are random processes. It's just like, if you want to think about random processes and how they work, just think about what's the average number of telephone calls you get an hour. So people don't get that many, I don't get that many calls except for people asking for money or students asking for grade changes. But say you get 6 an hour, but that doesn't mean that you won't get 10 in a minute. Right? That's what happens, and you have to keep people on hold. So just because the average is such and such, it doesn't mean that the probability that you'll get much more than the average is 0. Or it's not even 1/2, because you have to be careful about averages. Okay. Some people think that if the number of observations that are greater than the average and less than the average are both equal to the probability of that is 1/2, but it's not. You can get very easy counterexamples to that. Okay, well, let's not talk about averages. Okay, this Black-Scholes equation in our text is equation 13.16, page 355. Okay. Now let's look at this. And what I'm going to do, instead of deriving this with all this heavy-duty mathematics, I'm going to state it, and then we'll give it a nice interpretation. Okay, and this is going to be for a European call option with strike price K expiration time T of course, we're going to assume the start is 0, and interest, let's do away with that. We don't need that comma. Compounded continuously at rate R the price of the call option here we have a European call option, so we can exercise this at any time here. At time T, is, we'll say, call option if our stock price is S, and at time T equals S, that asset price or stock price, and D1. I'll explain what these ND1s are, and D2, minus K, e to the minus r, t minus t. T minus t is our time interval from little t to expiration, times ND2. Okay, now where we have, let's put this, let's circle this, let's highlight this here. Okay, yeah, that red shows up nicely. Where n of x equals 1 over 2 pi, the square root of 2 pi, times the integral from minus infinity to x of e to the minus y squared over 2 dy. And what this is the cumulative normal distribution. Now you have to remember that the normal distribution is used quite widely, but mathematically it's a little tricky. We have these numbers for departing from the normal distributions, but it's very hard, or it's impossible to really integrate it in closed form. But let's not worry about that. But that's one of the reasons that we use the Ito's lemma, the Ito calculus. Okay. Now, let's give an interpretation of this, which is very nice. So we have these two things, these ND terms, which are related to the cumulative normal distribution. Okay, let's give a nice interpretation. And I don't think this is in the book of our Black-Scholes equation. And that's the equation 1316. Okay. Okay. First, what we're going to do is to view the ND terms as risk-adjusted probabilities that the call option will expire in the money. Remember, we use these terms in the money, at the money, or out of the money. In the money means that our stock price at expiration will be greater than the strike price. Okay. So that's what we do. Now, let's look at our interpretation. This is a nice interpretation. Then, if both ND terms are close to 1, why don't we say sufficiently? This is what we typically say mathematically. So I won't say how close, but they'll be sufficiently close to 1. So that the call option would almost certainly, and I'm using some mathematical terms, English here, would be exercised okay. So if they're close to 1, then we know that there will be exercise, because remember the ND terms are risk-adjusted probabilities that the call option will expire in the money. Okay. So if it expires in the money, you know that the stock price is greater than the strike price. So what you can do is you can buy it at the strike price. Remember, a call option gives you the right to purchase, and then you can sell it at the stock price, and you make an immediate profit of S minus K. Okay. Then what happens? In C, S T equals S minus K, as expected. And C, let's look at CS, that's at any time t. Let's look at it at time 0 equals S minus K e to the minus RT. This is as expected. Remember, the value of the call option is what? The value of the call option is the maximum S minus K or 0, right? The value or payoff sometimes is called to the holder equals the maximum of S minus K or 0. Because if S minus K is negative, that means we will never do it, because we'd have to buy the stock at S and then sell it at K, okay? Now, let's see what else. Now, suppose they're close to 0. We'll say else if both ND terms are close to 0, when we say sufficiently, again, close to 0, then the option would almost certainly not be exercised. Remember, those ND terms are terms that we interpret them as terms that the call option will be in the money. So if they're close to zero, it means that they're out of the money. Thus, the option is not worth anything. Okay, it's that zero term. So let's look at that. So we'll say CST now we'll take T to be the time of expiration at expiration equals S times 0 minus K times 0 equals 0. Okay, which is exactly what we thought it would be here. So this is a very nice interpretation of the Black-Scholes pricing equation. Now, of course, we've taken the extremes here. So it's only an interpretation at the extremes. We didn't say anything about in between the extremes. So it's a little tricky, but I think it's a way to look at it that's, for a quick way to look at it, it's nice, without going through all the mathematics. Well, that's our continuous model. Let's see what else we have today. Oh, what we're going to do is we're going to do now and probably tomorrow, we're going to have a thing on interest rates. Because the whole course deals with interest rates. So I have a little handout on interest rates. And I don't know if, do all people have topics? I talked to somebody yesterday, a single person that didn't have a topic.
Most people do, I think. I haven't counted, but I think all of them should be.
There was one that was going to do a single one that I talked to yesterday, and I don't think he had a topic. Let me suggest for this person to talk about the recent LIBOR rate scandal. Okay. Another thing would be recent insider trading scandals, which have been going on, which have been quite interesting. I think both of those are great topics, and they're very topical. Not only are they great topics, but they're topical. Okay. Okay, interest rates. Okay. And we'll say, and the theory of capital. This is typically the thing that we study interest rates in, something called the theory of capital. Okay. Now, There are a lot of different interest rates, and we're going to go over them. There are things like you always hear about the prime rate. You might hear about Bernanke's always talking about they're always talking about the federal funds target rate. You might have seen that there's scandal in the LIBOR rates, and there are a lot of different interest rates. And then you might say that why do U.S. mortgages, why are they based on or a little bit above the so-called LIBOR rate, which is the London interbank interest rate? You say, who cares about London? Well, that's just posted in London, but there are many U.S. banks involved in that. So a lot of times things look strange. You should understand these interest rates. Now, let's first do the following. How are interest rates determined in the marketplace? Okay. These are, of course, rates that are not set by some numbers of people or set by the federal government. But these are just, suppose the market was going to price interest rates. Let's see what we have. The market, when the market prices something, it prices something according to the law. According to the laws of supply and demand. Okay, so let's look at this. I think we were at 8, no, 9, 10. Okay. Let's look at this graphically. Graphically, we have the following. Suppose this is the interest rate here, and this is dollars. Okay. Now, let's look at two things. Let's look at supply. We'll say this is our supply curve. Why? As dollars go up, our interest rates go up. As we want to supply more and more, and you could think of this as, in a bank, as savings. The bank has a number of people that are saving for it. Then you can look at demand here. So if you have a high interest rate, you will have less demand, and we'll think of this as people borrowing from the bank. Okay, now let's look at what happens. Now, first we'll come across here. This is I star. This is the market interest rate. You can think of that as the rate set by the market, okay, where the supply and demand curves intersect here. Now, what happens here? Suppose we get an increase in supply. Suppose we get an increase in supply. the supply of money. Then what is going to happen? You're going to see that the interest rate will go down. Okay. The interest rate will go down, which makes sense. Now we have more money in the economy, so the interest rate should go down. Now let's shift the demand curve. Suppose we have more demand for our money. Now we're looking at more demand for our money, and what's happening here is that our interest rate goes up. Let's call this prime. Okay, let's write that out. So we have if our supply what do we call this? That if the dollar supply increases, the dollar supply increases means what? The curve moves to the right. Then, what do we get? That curve moves to the right, then the market interest rate and we'll let that equal I prime here, that was our I prime, goes down. In other words, I prime is less than I star. And if the dollar demand increases, likewise moves to the right, what we had here, so on the horizontal scale we have money. Then what happens? Demand increases, then the market interest rate I star star goes if the supply increases, let's look at this. This goes down. Goes down. So this is what this means is that I prime prime is less than I star. Okay, which makes sense. If you've got a lot of demand and only a certain amount of money, and that demand increases, then there are more people who want to borrow money. So the way to get equilibrium there is to set the interest rate going down. Now this is if the market decided decides the interest rate. Both of these assume that the market decides the interest rate. Assume that the interest rate is determined by the market. But in fact, this is really not the case. We have other things that determine our interest rates here. Now, what we're going to do, we have something we put up on Blackboard. On Blackboard, we talked about specific we gave or we put an interest rate handout that talks about, describes other than market interest rates. And here we describe things about the interest rates or yields on government notes and bonds. We also talk about the federal funds target rate, which is between 0 and 0.25%. And we talk about the prime rate and the LIBOR rate and some other rates, the discount rate. So we're going to go over these important interest rates tomorrow. I think we're going to end a little bit early today. And tomorrow, when you'll have a chance to look at this, and in fact, we put up a little thing on the LIBOR also. So you may want to look at that. Okay, thank you very much. For the most part, people did well on the test, but some people didn't do that well. I encourage them to do the rest of the homework and extra credit and try to do a good job on your project. Okay. Remember, if you want to make your presentation this week, say Thursday or Friday, or Monday or Tuesday of next week, we're going to add some extra onto your project grade. Okay? Okay, thank you very much. I hope it's a little cooler where you are. Today, the market, the last I looked, the market was down a little bit. But we've had a big run on the market. Like I did say, that we had a 14-day run on the NASDAQ 100 here. We had a big run up on the market, so we're due to have a small correction anyway. Okay, thanks a lot. And we'll see you next time.